5 years ago, I calculated how much energy Sonic released in his Energy Surge Blast. Now we're doing it again, but way better. Okay, let's think. How can we calculate that energy? Well, I know that the explosion was spherical and isotropic, meaning it's equal in all directions. And his blast reached a satellite. See, right here. So the surface area of the spherical blast touched the sphere. Wait, that means that we can multiply the energy density that reached the satellite by the surface area of the sphere at the level of the satellite, and that will give us the total amount in energy, in joules. Let's start with surface area. Okay, the surface area of a sphere is 4 pi r squared. 4 is a number, pi is a number. Where do we get the r from? Well, the r would be the distance between Sonic and the satellite. Now, I'm imagining that the satellite was just above Sonic. Yes, the distance could be a lot more than that. But let's just say that it was just right above Sonic. There are 3 different orbits for satellites, LEO, MEO, and GEO. But based on that, we see the satellite near Earth and it moves relatively quickly relative to Earth. We could say it's a LEO, which is from 500 kilometers up to 2000. Let's just say a humble 600 kilometers. Again, this could be a lot more. So 4 pi r squared, 4 times pi times 600,000 squared, it gives us this big number. We're just gonna copy it, okay? 4.52 times 10 to the power of 12. Now what we have left is the energy density. And how do I find that?
I have no idea. I have no idea. I have no idea.
Wait, I have an idea. Listen to this.
An energy surge knocked out power across the entire Pacific Northwest.
Okay, that's better. Green Hills is in Montana, a US state. And we can say that this is the Helena part of Montana. And by looking at Green Hills in the movie, yeah, I can see the resemblance. So now I want the displacement between Sonic and the Pacific. And what's that? 1,200 kilometers. Now, as you get further and further from an explosion, it becomes weaker. So, the end of the Pacific, is the last point that we know of, could be more, where the power got cut off. So that means even after this entire 1,200 kilometers, there was still the threshold energy required to cut off the power. And according to my research, it would be 10 if weak, 50 if meh, and 150 if strong. And based on...
Well, our first instinct was it was an EMP. But electromagnetic pulses don't have that kind of power.
So 150 it is. Could be more. What's this got to do with the satellite? Well, using the inverse square scaling, the Montana is a 2R. How do I know? Well, R is the satellite, which is 600 kilometers, and Montana is 1,200, the double. Since the satellite has half the distance, that means it will have not double, but double squared. So 4 times the energy density of the Montana calculation. So that 150 multiplied by 4 gonna give us 600 joules per meter squared. At satellite level. Yes, we actually finally did it. Back to the equation. 600 times the surface area gives us this number. Yeah, we'll just say it 2.71 times 10 to the power of 15 joules. Wow, that's a big number. You could charge 75 billion, not million, billion, iPhones to 100%. Do you know what that means? That means if every single human on Earth had not 1, but 10 iPhones at 0%, and this blast charged them, every single iPhone on Earth would charge to 100% at the same time. Again, every human on Earth has 10. Can you imagine that? Or we can say free energy for Green Hills for 70 years. Or 10 atomic bombs. Wow, that's really powerful. Just from one emotional hedgehog. And the thing is, Eggman recreated it in the second movie with just one quill. What about the rest? How much power does this hedgehog really have? If you're interested and want to watch my 5-year-old one, you can watch it right here. Well, it has a lot of wrong calculations, but it's worth a shot. If you feel like there's anything wrong with this calculation or you want to comment about it, please do. And by the way, as I said before, this number could be much higher. This enormous number could be actually much higher. If the satellite is further, if it's not a Leo, if, it could be a much higher number. And I'll see you in the next video, guys. Bye.